start the class. Okay. So today we are going to start with chapter 2. Chapter 2 is talking about a wireless spectrum for 5G. But before that, I hope you do not drink or eat in the classroom. Okay, so before that, I think it's quite important to know why we have to implement 5G, right? Okay, so I will start with Nokia Portal courses first. And for Nokia Unit 1, there is 2 portions. For the first one is talking about drivers and technology, which will be applied in today's network to improve the operation efficiency. Okay, like we want to boost the connectivity, right? So how can we boost the speed to make the connection more faster? There's many ways. Remember, in week 2 or week 3, we talk about the radio modulation, because the first part of the 5G network is radio, right? So basically, the network should construct with 3 main units. First one is radio unit. How can we make the radio transmission more faster? Remember, we have been talking about modulation, right? How can we deliver the data through the radio? We use AM, FM. We use amplitude, or we use a frequency modulation, right? But it was not efficient enough. How can we increase the speed? There's 2 ways. The first one is carrier aggregation. The other one is dual connectivity. So when we going to buy the cell phone, it may have a remark to talk about if your cell phone support CA or DC. If your cell phone does not support, dual connectivity, it's useless. It cannot work. If your cell phone does not support carrier aggregation, so even though you connect to the 5G network, you will not be able to boost up your speed, connection speed, right? Okay, but how can we improve that? That's what we are going to go through. And remember, last week we visited the Smart City Expo, right? And we have visited the Chunghwa Telecom booth, and also Far East Telecom booth. So they have been demonstrating some application scenario to us. Like Chunghwa Telecom, they have demonstrated the low orbit. I know you probably did not see that, but I didn't know if you go to visit their booth or not. But I post this in our GitHubs, so you can go to check. Anyway, for 5G network, mostly the radio station is on ground, right? But when we talk about 6G, the radio station could be in air. Okay, that's a satellite. But with satellite signal, you probably need to have the antenna to receive the satellite signals. So you may need to have a satellite phone, but not a cell phone you have. Anyway, I want to tell you is you need to clear about what kind of facilities can use to connect it. For example, if you are going to connect it to the satellite radios, you need to have the devices with satellite radios. Okay. And so we have to know the spectrum. That's what we are going to talk about in chapter 2. Okay. But before year 2015, we only talk about the frequency under 6 gigahertz. This is not talking about generation. It's talking about gigahertz, the frequency. But after 2019, the 3GPP start to discuss the higher frequency. Okay, because we are going to have more devices get into the network. It's necessary to have a wider spectrum, okay, and an even faster connection. So the application extended to the 6G gigahertz to 30 gigahertz. So it becomes two categories. The radio wave between 6 gigahertz to 30 gigahertz, we call this is a centimeter wave. Okay. But if it is even higher, we will call this is a millimeter wave. Okay. So for transmit this, we will have two different ways for the data transmission. But the modulation way, the first one is called FDD, frequency division difference. The second one is the time division difference. Okay. All of this is trying to make the data transmission more reliable, but more faster. But we know there is many applications. So you have to select what kind of data to deliver with different modulation mode. Okay, so we will use OFDM, or signal frequency division multiplexing. Because in one scenario, you may use different kind of frequency for different devices. Okay. For example, let's look at last week. I post pictures here. That's it. For remember these devices. I know it's not clear here, but here shows DU, CU, RU. Right? These will be the antenna which used to receive the different resources. So, as you can see, that's a system which will provide information to the control center, but it's operated in a very wide area. The operation area should be able to cover the whole Taiwan. I mean the railway. Here they want to check all the train on the road for safety, to prevent the collision. Right? Okay, so how can we construct the network is what we are going to learn in this class. Okay, I will not, go through our hangout one by one, but I try to make the connection to make you understand how to construct the system. And at the end, last hour, we will have exercise with free 5G call. Okay, so Manel will work with you to figure out how to use the software. Okay, so first, let's look at the go here. The chat. I put a class note here. This property is everything that you should remember, I think. Okay. So last week we have visited the Smart City Expo, right? And we have been seeing the multi-orbit satellite connectivity service. Okay, and we know the digital twin technology for smart railways. And also Far East Telecom, they demonstrated the hydro monitor operation service and also AI sustainability solution for hydrogen, solar, and energy storage. Okay, so that's what we have been seeing. That's the orbit, the satellite, right? And that's the application. Okay, I think you know this, right? So, but how can we construct that? The first, we have to know how to select, the wireless spectrum, which can deliver the good signals. Okay, so usually we may have FDD, TDD, and also for the machine type communication, usually it will be running under 1 gigahertz. And we know for high speed data throughput, we have to consider to use centimeter wave. For even higher data throughput, we have to use 30 to 300 gigahertz. It will be very high, so it's much easier to get lost the data. But we also have some band, radio band, we call the ISM. It's for industrial, scientific, and medical service. It's free. Okay, it's an unlicensed band. In the United States, they use 950 megahertz. In Taiwan, we use 920. But in France or Indonesia, you may use different frequency. But once you use this kind of bandwidth, you have to be very careful. Why? Because this will be used for ambulance, police. Okay, so if you abuse this, you will violate the regulation, even the law, because you will interrupt some police operation, you will get caught seriously. Okay, so you have to be careful. Once you are going to set up some radios, you have to, for receiver, it's okay. Like in our class, we have, Maneo have demonstrated some devices, receiver, right? Receiver is okay, but once you are going to transmit the data, transmit the radios, you have to be careful. Okay, and the common use band, this is important. The band 75 to 79. Usually for our cell phone, we use N77 and N79. I know it's not very meaningful to you, but once you are going to construct a network, probably you have to know what it is. Like the band 75 and the 76 is so-called supplementary download bands. It's used to, to increase, like I just said, if you are going to increase your transmitting speed, you may need to double the channel, like that. Okay, so it's a supplementary downloading bands, which all have only downlink transmission without a corresponding uplink, so it can only use to be downloaded. So also some idea for bandwidth is a carrier frequency in the lower sideband and upper sideband, and antenna radiation patterns. Okay, so in Nokia, you need to what? It should not be here. So. Sorry, I mixed up. This should be for next week, right? Why I put this? Sorry, I did not update. This is for next week. Okay, but I think it's good to know this too. Okay, the radio evolution is centralized, current architecture. So it's classical RU plus the baseband unit. So that's a radio unit plus a distributed unit and link to CU. Okay, I know it's not easy to understand, but if you look at our hangout, that will be much easier to understand. Okay, so let's look at the first slide. That's unit 1. I will prefer to start with 2 first. Okay, I will prefer to start with the industrial journey to 5G. What is this? Basically, the system will be like this. I mean, in this course, we will start from imperative. We will learn why we need to have the 5G, and we will learn the 5G networking. That's RU, right? DU and CU. That's called distributed cloud. And how can we achieve the low latency and the massive connectivity? It's based on the network slicing, because we need to guarantee the quality of experience. user experience, QoE, right? And the security is majority issues when we are trying to implement 5G. All of this is trying to achieve the industrial automation. Okay, so what will be benefit? What 5G will benefit to today's technology in the manufacturing, transportation, health, sports, entertainment, and public safety, mining, and the power industries. Okay, so first, let's look at the manufacturing. Today, what we have, manufacturing process automation, right? It's very common, automation. But what's tomorrow? Tomorrow, we hope we can have a dynamic production control, capacity, and agility. So the robot can be smart, just like the people. You will be able to create the status change. For example, some machine is broken, but if you are based on the traditional automation, the robot just follow the rule, the logic. They will not be able to respond to the changes. Okay, but in the future, we want to do this. What we should have? We have to implement more sensors, more devices, collecting more data. That's what we call data-driven manufacturing, right? Industrial 4.0. And how about transportation? Transportation, today we know the fleet management. When you call Uber, when you call a taxi today, they will be able to patch the taxi for you automatically. But how about the futures? We hope that this will be more dynamic with a shorter distance, something like this. Okay, so that's tomorrow use case. So that's what we need to have, the 5G. And then also for healthcare. Today, we can share in real-time health data. I believe you have visited some booths in Expo, right? And some company, they deliver some solution like this. That's today what we can do. But in the future, we are going to have a remotely supported company's health interaction. So what can we do? We need to have we need to have a higher video resolution and a higher speed, the network bandwidth, which can deliver the video with more details. So the doctor can examine the information to help patient remotely, and even with the AR, VR devices. And for sports entertainment, today, I think everyone have been, visited some audience, right? But the problem is what? Once you are in the audience and then you watch the game, sometimes you want to know the players' information. You cannot catch that, right? So you have to have your cell phone and to get the TV information or some online information, right? But in the future, if you have AR glasses, okay, you can get the real-time information, and then you can even know how fast the running speed of the players, right? With AR, they can get this kind of information, and then you can know how much energy, the player still have. Depends on, some physical records. Once the player run up to maybe half hour, up to 1 hour. How long is one soccer game? 45 minutes. Usually it's 45 minutes for first half and second half. Total is 90 minutes, right? Sorry, I'm not familiar with the soccer game. So you will be able, you want to get this kind of information immediately. But how can we achieve that? You need to implement the 5G, so people can have a 5G card, can have a glass, to get AR glass, to get a real-time information. And also, do you know the Apple Watch? No, not watch. Apple glasses. Apple glasses. Apple glasses, they can use to play golf. When you play golf, you want to know information about the wind, right? You want to know the weather because the wind will affect, the ball flying past, right? So you want to know the wind direction, how strong the wind, right? But before, if you don't have AR, you have to check. You have to use your cell phone to check the weather information, the wind, strong direction, like that. But if you have AR glass, you can get this information immediately. Also, public safety. What is today? That's what we have. Video surveillance is very common, and to recognize people's face. That's what we can do today. But how about in the future? In the future, we want to have a proactive threat recognition by radio, right? And we have to enable by end-to-end 5G to have a massive connectivity for multiple video feeds and the cloud-based autonomous recognition, autonomous. So that means you have to implement something like AI. With AI, you need to have, computing resources, more computing resources. Okay, also mining. Today, what we have, human remote control large earth digger, right? You can digger remote control. Okay, but tomorrow, you don't need to remote control. Why? Because the digger, they are autonomously. They know where is the mine. They know the target. They don't need the interaction of human. And also power industries. Okay, anyway, that's what we need to, that's why we need to have a 5G. So at the end, they give examples. It's about the port of Hamburg. Hamburg is in Germany. So this example is they are trying to implement 5G to the port. Okay. We know the port usually is cover very large area. So in this case, they use the 350 kilometers of fiber and the various radio technology and the 9 early stage 5G Wi-Fi access to support a stringent service level agreements. So if you are a telephone company, how can you implement the network? Okay. At the end, they increased the container handling volume from the 9 million unit to the 18 million unit. But how can they do that? Because they increase the sensors from the 10,000 to 100,000. But how can they do this? If we think of 5G, you may think, oh, I know we have devices and we have a SIM card, so we put the 5G devices on all containers. No, this is not going to work. Because the 5G is pretty power consuming. And if you are going to cover so many containers, how can you manage this? It's very difficult. Like the U-bike, the U-bike in Taiwan, in Taipei, not in whole Taiwan, most of the cities do have U-bike. How can they manage so many U-bike? The U-bike use NB-IoT, narrowband IoT network, but not 5G. I didn't know how do they implement this. Probably they use RID or some other low power communication technology. Maybe LoRa, maybe Sigfox. I don't know. But that's what we have to study. But everything should be under the 5G core control. 5G should be able to cover everything in the network. So that's why they can use the same facilities, but work in more efficient. Because they know the location of the containers, they know the equipment's locations. Okay, so we will have a break a 2:20. Okay, so. In this module, we will be able to distinguish the three limits driving us toward end-to-end 5G. First is consumer value creation and the current network and the total cost of ownership, and explore business trend and the technology evolution for facilitating the fourth industrial revolution, and applies the importance of a new automatic solution. So first is talking about the limit, consumer value creation, and the solution is a new industrial infrastructure. So traditionally, the provider stage nation is around in 2050 is TV is 200 and the voice is 322, for data is 479. But to the year 2019, previously the data stage length is increased, and the voice is getting less. But for TV, it seems doesn't have much change. But you do like people use the voice so it's less, but still keep the TV and data. Okay, so that's the trend. People used to use data more, and some growth, but not for all. Like video. Video means VOD means video for on demand streaming. This kind of service increased, and also cloud involved so we call ICE. This is also increased. So way as service increased. Also business processes as a service increased. And also cloud advertising increased. So once we look at this kind of information, we know where to put our effort on this. Okay, what do you think? The consumer market have become higher matured. Where can new value be found? Okay, so that's a question. And let's answer this. First one is there are still untapped consumer market segment just waiting to be found. The second is exhausted or viable option developer society have entered post-growth. And the last one is hidden in plain sight in infrastructures and various industries and enterprises. The last one, the first one is not correct because we won't be so sure about that. In fact, growth opportunities are hidden in plain sight. We just need to look at things the right way. And the second one is not correct also. The odds of shrinking growth in consumers-driven application are slim at best. And last one is not clear, but it's correct. That's right. Growth opportunities are indeed hidden in plain sight. We just need to look at things the right way. Okay, here is digital opportunities of various industries. Okay, here give us some information for past and present value creation. In the second industrial revolutions, we introduced, the electricity, right? So the productivity increased, and in the early stage of the three industrial revolutions, we implement the computer, we digitalize, the manufacturing systems. Why the productivity did not grow? Why? Because we only collecting data, but not really use the data, and the data may be not fine enough. So that means we need to have more details. At this moment, we still don't implement too much IoT solutions. Like the example of the paw of the hamburger, right? They increased their sensors from 10,000 to 100,000. So they can have more detailed information about the real operation. right? Okay. So in the next step is Industrial 4.0. We call the data-driven manufacturing. Data-driven. So we need to have more data. So we need to have more sensors. So we need to have a more rugged network. However, the digital industries is not create much GDP. We still need to focus on the physical industries. That's why President Trump want to bring manufacturing back to United States. I think United States, they do have a very good software industry. Like you can see the Microsoft, the Google, even the social media, they do have a Facebook, Instagram, many big companies. At least will only occupy 30% of GDP. For physical industry, it's more important. Okay, so, but if you want to make your physical industries more stronger, working more efficiently, you need to have 5G. Okay, later is about the use case. So we will take a break. So please come back around 8:35. Okay, let's take a 10 minutes break.